Hello guys, let's talk about ionic compounds. What are these compounds? These compounds are generally formed between a metal and a nonmetal, such as NaCl, and they are electrically neutral. So indeed, my favorite salt is stable salt, which is NaCl. We talked about the fact that sodium would like to lose an electron to become a sodium ion, and chlorine likes to gain electrons to become a chloride ion. So let's see how this happens again. So when we have a sodium atom, it can lose an electron to become Na plus, okay? And then chlorine can gain an electron to become Cl minus. And actually, the same electron that sodium is losing goes to chlorine to form a chloride ion. So there is an electron transfer from the metal to the nonmetal to form extremely stable compounds. All right. Now, if you have a metal and a nonmetal, how do you figure out what is the formula between them? So sodium chloride is NaCl, right? And since we know that these compounds have to be electrically neutral, we can do the following. We can write out the metal ion and the nonmetal ion and use their charges as subscripts in the formula. Okay, so Na1, Cl1. That would be NaCl. We just do not write the one. Let me give you another example. So let's say that we have a calcium ion, Ca2 plus, and N3 minus. So we want to make a neutral ionic compound from here. So we can take the 3 from the nitride ion, that's how it's called, put it as a subscript for calcium, and take the 2 and add it as a subscript for nitrogen. Okay, so the compound that I'm going to get is Ca3 and 2. Okay, let's check the charges. So for calcium, we know that it's 2 plus times 3 is going to give us a 6 plus charge overall. How about N3 minus? For that, we know that we have 2 times 3 minus is going to give us a 6 minus charge. So 6 plus 6 minus will give us a net 0 charge. Okay, I hope this makes sense. Let me give you another example. Let's say we have calcium again. Calcium is 2 plus, and the oxide ion, which is 2 minus. Okay, so I would take the 2 here and the 2 there. And what I end up with is Ca2O2. Do I really need the 2 and the 2 next to the calcium and the oxygen to make an electrically neutral compound? No, not really, right? Because both have a charge of 2, 2 plus, 2 minus, so they cancel each other out. So in this case, I will have to reduce to the lowest whole number ratio. So the correct formula is CaO. All right, let's do one more, just in case. Let's do aluminum. Al 3 plus, and let's do oxygen again. 2 minus, O2 minus, the oxide ion. So the 3 goes down there, the 2 goes down there, and I'm going to arrive to a formula which is Al2O3. Let's double check. So aluminum is 3 plus, and I have 2 of this ion, so I have to multiply this by 2. This is going to give me a 6 plus charge, and oxygen is 2 minus, which I am multiplying by 3. That is going to give me a 6 minus charge. Okay, so they are equal. So overall, I have a neutral ionic compound. Okay, so how do I name these compounds? Well, I have to use the so-called chemical nomenclature. It is the system of naming compounds. When I have a cation, I will have to use simply the name of the cation, like the sodium ion, Na+. Now, in some cases, when the cation can have more than one possible charge, I will have to add the charge as a Roman numeral in parentheses. So these are mainly transition metals, okay? So for example, iron is a transition metal. So when I have an iron 2 plus ion, I have to show it as iron 2 ion, and it is also called the ferrous ion. Okay? All right, one more example. What happens when I have polyatomic ions? And polyatomic ions, just ions that contain more than one atom. In that case, the name will end with "im". So NH4 plus is called the ammonium ion. All right, what happens when I have anions? So if it is an element, then it should end with "ide". So Cl minus is going to be the chloride ion. And if it's polyatomic, I just have to simply use the name of the polyatomic ion. For example, the SO4 2 minus ion is the sulfate ion. Okay, let's practice and let's try an example. Let's say that I have NaCl. I know that Na plus is called the sodium ion and Cl is called the chloride ion. So when I put the two together to form an ionic compound, I'm going to call this sodium chloride. Okay, what if I have a compound between iron, some kind of charge with iron, let's say iron 2 plus, and Cl minus? So first of all, if I have a compound like Fe2 plus and Cl minus, I have to figure out how to write out the formula. So I will have to move the charges as subscripts here and here. So the formula is FeCl2. All right. What is the name of the Fe2 plus ion? Iron 2 ion. Now, I'm not going to use the word ion. I'm just going to simply say iron 2. Notice that there is no space here between the iron and the 2. Iron 2 chloride. All right, I hope this makes sense. Let's do a couple more examples. So what if I have an Al3 plus ion? Where is aluminum in the periodic table? Let's try to find it. It's right here. Is it a transition metal? No, it is not a transition metal. So aluminum 3 plus is actually going to have the name of aluminum ion because the only possible charge on aluminum ion is 3 plus. Okay, let's move on. Copper plus. Where is copper in the periodic table? You find it? So copper is here, element number 29. Is this a transition metal? It is, right? So we know that most of the transition metals can have multiple different charges. So do I need to show the charge as a Roman numeral in the name of this ion? Yes, indeed. So the name of copper plus is going to be copper 1 ion, and it can be also named as cuprous ion. Okay, how about iron 3 plus? Where is iron? Did you find it? So iron is right here, element number 26. Okay, is it a transition metal? It is indeed. So I probably have to use a Roman numeral again. So I'm going to name iron 3 plus as iron 3 ion. It can also be called ferric ion. Okay, copper 2 plus, we are back to copper. So it should be really simple, right? It's the same metal right here. I have to use the Roman numeral to show the charge. So it's copper 2 ion. It is also called cupric ion. Now notice the difference or the pattern in the other type of naming, in the Latin naming. This is an older version of the nomenclature, but it's still used. So if you have a lower charge, the ending ous is used. If you have a higher charge, the ending is ik used. So the same goes for iron 3 and iron 2 plus. Iron 3 plus is going to be ferric ion, and iron 2 plus is going to be the ferrous ion. I think it is the most important to remember at least one type of nomenclature. I definitely suggest you to try to remember using the Roman numerals as we did here. Okay, what about the F minus ion? Is it still a cation or is it an anion? It is an anion, right? Where is it in the periodic table? It is number 9. So, because it is an anion, we have to add the ending "ide" to the name of the elements. This is going to be a fluoride ion, okay? There is the "ide" ending. And the last one in this example is oxygen O2 minus. Again, we have a monoatomic anion, right? It consists of only one type of atom. So what would be the name? Again, we just need to add the ending "ide" to the oxygen. Oxide ion. All right, I hope this makes sense and see you in the next video.